So take a look at these 2 points here. If I draw the line connecting them, I get a horizontal line, which turns out is a little special. All right, so let's take a look at some of its properties, kind of see what happens here. First, and let's just kind of do the obvious thing and see if we can find its slope. Well, first, notice it goes through the points 1, 2, and 8, 2. And now I put those points into our slope equation. Remember, it's the difference of the y's. That's 2 minus 2 over the difference of the x's. That's 8 minus 1. Well, 2 minus 2, that's 0. 8 minus 1 is 7. And 0 over 7 is 0. Okay. That's a little unusual, and this is really kind of the key takeaway from this particular slide. It's perfectly okay. Every once in a while, I'll have a student, he gets 0 for the slope, and for some reason in his head that becomes a problem. 0 is just another number, and there's nothing wrong with getting that as the slope of the line. Okay, how about the equation? Let's go to our point slope equation. Right, remember that's y minus y1 equals mx minus x1. And it doesn't matter which point we use. I'll take this one here for no other reason than that the numbers are a little smaller. And put those into our equation. This becomes, let's see, y minus 2 equals 0 times x minus 1. And this right side is nice now, right? 0 times anything is 0, so this is y minus 2 equals 0, or y equals 2. And this is the second kind of interesting point about these horizontal equations. We ended up with one that only has one variable. Right? And that's really going to be the key indicator that you look for to determine if a given equation represents a horizontal line. And another thing that I really want to stand out to you, notice that this number here is the same as the common y coordinate at our 2 points. Right, so these are both constant things that you should always associate with horizontal lines. Horizontal lines are always going to have a slope of 0. Every horizontal line is the same in that respect. And their equation is always going to simplify to y equals a number. All right, so now let's try going the other way. If we talk about horizontal lines, well, what can we say about vertical lines? You see, that's what I have here. The line through these points is vertical. So let's kind of do the same process here. If we think about the slope, this line, the 2 points on it are 1, 2 and 1, 8, which means the slope, I'm going to do the same thing, difference of the y's, that's 8 minus 2, difference of the x's, that's 1 minus 1, 8 minus 2 is 6, 1 minus 1 is 0. And now we've run into a little trouble because you can't divide by 0. That's not allowed. All right, so what's the answer here? Because the fact that we ran up against this obstacle doesn't get us out of answering the question. All right, so my answer here would be, there's 2 ways I would say this. Either I would say the slope is undefined, or I would say the slope does not exist. Those are the only 2 ways that I would say this. Please do not, I see some students, they get a little weird and they try to do this. Please don't try to say that this equals infinity. No, absolutely not. 6 divided by 0 is undefined. It doesn't exist. You can't do that. And that's really where the conversation about the slope of a line is going to end. All right, so how about the equation? Okay, I'm going to do something here. And I can't believe I'm going to do this in public where anybody can see it. But I'm just going to give you fair warning here, okay? Do not try to repeat what I'm about to do anywhere. I am going to do this purely because it illustrates the point and helps you to see where the equation comes from. Right? What I'm going to do here is I'm going to start with our point-slope equation, just like we did with horizontal lines, and I'm going to pick this point here to work with. Again, you can use either one. The numbers are a little smaller here, so I'm hoping that makes my life a little easier. And you get y minus 2 equals, let's hold on to that m part for just a minute, leave a space there, x minus 1. Now here's what I'm going to do, and this is the step that you should absolutely not repeat under any circumstances. I'm going to take that 6 over 0 and put it in here. I'm going to politely ignore the fact that it's not a number and that under no circumstances should I treat it like a number and use it like it is. Right? Because now if we're going to do this polite little fiction, I can multiply both sides by 0. Right? I can do times 0 here and here. The right side simplifies to 0. The zeros nominally sort of cancel over here. And all that's left is 6 times x minus 1. Now if we divide both sides by 6, we get 0 equals x minus 1, or x equals 1. And there's my equation of this horizontal line, right? So what do we take away here? Well, first notice that this was kind of the reverse of what we saw with horizontal lines. Horizontal lines always ended up with one variable, y equals a number. Vertical lines always end up the same way, but with x as the variable, it's going to be x equals a number. And again, just like we saw with the horizontal lines, this number here is the same as that common 1 in our 2 points.